Welcome to class, everybody. As I mentioned at the end of last class, we're going to start our section on descriptive statistics today. And at the end of last class, I just spelled this out. Descriptive statistics, there are 5 of them. This is a set of procedures in which we organize, summarize, and present data. So during this whole presentation, class discussion on descriptive stat over the next couple of weeks, if you're ever sort of like wondering what we're doing, this is what we're doing. We're organizing, summarizing, and presenting data in the form of frequency distributions, central tendency, dispersion, position, and relationship. And there are individual chapters, of course, which outline. Let's start with frequency distributions. With frequency distributions, we're essentially dealing with counts. We're dealing with counts, counting things. So a frequency distribution is a distributional count keyword here being count of, you know what, just about anything you want to count, of scores, items, or whatever's being measured. A frequency distribution is a distributional count of scores, items, or whatever's being measured. And the woods is full of frequency distributions. You know, 32% of females surveyed said they preferred 17% of the prefer this. You know, typically the results of frequency distributions are presented, as percentages. And again, chapter 2 in your textbooks does a fantastic job. And I hope that during the weekend you studied and went over chapters. All I want you to do, if you notice there was no real assignment for chapter 2 other than just to read, I wanted just to see what they're doing. So you saw all kinds of really cool pictures and graphs and charts and all kinds of things. This is pretty much what they're doing in chapter 2. Let's suppose we took a survey with 50 people, and we asked these 50 individuals, how many cars do you have at home? How many cars do you have at home? And so we can draw this simple little frequency distribution with X, frequency, and the P for proportion. And we can, convert proportions into percentages. And as it turns out, X is 1, 2, or 3. A 1-car family, or a 2-car family, or a 3-car family. As it turns out, 20 people told me that they have 1 car at the house. 20 people told me that they're a 2-car family. And 10 people told me that they're a 3-car family. And if we sum the frequencies, we get 50. The sum of the frequencies always equals n. Pretty simple. And again, you guys, remember I said this course starts out pretty easy. So this is another one of the easy, this easy stuff, all right? Real basic stuff. We can convert these into proportions. 2 times 50, 0.4. So about 40% of our individuals are a 1-car family. Now, but suppose we had 5 million subjects. See, these frequencies, thank God we have computers, right? But these frequency distributions get really big. This is a really cool way of reporting things, and they do that in chapter 2. 20 divided by 50 is 0.4. So about 40% of the individuals surveyed are a 2-car family. 10 divided by 50, 0.2. About 20% are a 3-car family. And If we sum the proportions, we get 1. If we, 1 or 100%. So if you're looking at these frequency distributions in Chapter 2, the sum of the frequencies always equals the number of scores. The sum of the proportions always equals 1. If you were to convert these to percentages, the sum of the percentages would be always 100%. So this is pretty easy stuff. Let's just continue this a little bit. Let's suppose we sampled another 50 people. Our small n is 50. We asked them the question, are you in favor of the 4-day work week? Are you in favor of the 4-day work week? Are you in favor of the 4-day work week? I've actually worked some 4-day work weeks, and they're pretty cool. Get it all done in 4 days. You got 3 days off. Well, again, we could construct another simple frequency distribution where we have the score. X is always the score. X is the score, frequency, and proportion. In this case, we have opinion. We have opinion. Yes, no, maybe. And as it turns out, out of our 50 people, 22 stated yes, I am in favor of the 4-day work week. 23 said no. And 5 said maybe. Now, if you're familiar with political polling, especially around election time, and you have a real close race, and then you see that undecided, the undecided folks could kind of go either way, and sometimes, have a pretty significant effect on the results of the election. But anyway, let's convert these to proportions. And again, the sum of the frequencies always equals n, which in this case is 50. Sum f always equals n. We can convert to proportions. 22 divided by 50 is 0.44. 23 divided by 50 is 0.46. 5 divided by 50 is 0.10. So again, about 44% are in favor. 46% are not in favor. 10% are kind of on the fence. And we know that sum p, the sum of the proportions always equals 1. Pretty easy stuff. Pretty easy stuff. Okay. Let's extend this a little bit. Let's suppose we have 15 students and we give them a 5-point quiz. We have 15 students. We administer a 5-point quiz. We grade the quiz, and here are the scores. Fifteen scores. We have a distribution, and if you're wondering what that term actually means, it just means a set of scores. A distribution is a set of scores. And whenever we have a distribution, the very first thing we do, this might sound really simplistic, the very first thing we do is look at it. We look at it, because it immediately tells us something. Look at this distribution. What is it telling us? Well, it's telling us that they didn't do real well. Look at all these 1s and 2s. And I did put this distribution in order for you. you know, yeah, they, you know, that these kids didn't do real well. There was only one individual who got 5 out of 5. Well, we could construct a frequency distribution very quickly. X, that's the score, frequency, proportion. And our numbers are 1, 2, 3, 4, 5. And if we just eyeball this distribution, it's obvious, right? We have 5 1s, 4 2s, 3 3s, 2 4s, and 1 5. The sum of the frequencies is 15. We know the sum of the frequencies always equals n. And again, we can create proportions. So this is pretty much what Chapter 2 does. Look at the cumulative frequency distributions in Chapter 2. This is kind of what they're doing, okay? And I don't want you to stress about this. If you notice, I didn't include any exercises. I just want you to be familiar with what they're doing. Frequency distributions are kind of a no-brainer. That we have a lot more work to do. We need to focus on more things, okay? This is pretty simple stuff. 5 divided by 15, 0.33. So we see about a third of the class got 1s. That's pretty obvious here. 4 divided by 15 is 0.27. 3 divided by 15, 0.20. 2 divided by 15, 0.13. 1 divided by 15, 0.07. And if we sum the p's, we get 1. And if these were percentages, of course, the sum of the percentages would be 100%. But again now, this is telling us something. Yeah, 33% scored 1, but if you look at this, the area from here back, about this plus this plus this is 80%. About 80% of the class scored at 3 or below. About 80% of the class scored at 3 or below. See that? Not real great grades. Chapter 2 might do, take this kind of a distribution and present it like this. We have x on the x-axis, frequency on the y-axis. We have 1, 2, 3, 4, 5. And now we play match them up. X is 1, F is 5. X is 2, F is 4. 3, 3. X is 3. X is 4, F is 2. And X is 5, F is 1. And instead of playing connect the dots like I would if this was something linear, remember this is one variable. One variable. This is a univariate statistic. One variable x. Chapter 2 might do something like this. It'll create this pretty little picture, and you probably saw a number of these. This is either a bar chart or a histogram. Organizing, yes sir? Oh. Organizing, summarizing, and presenting data. And the first way we can do this is with a frequency distribution. So you look at this picture, and of course if you can interpret graphs, which we hope that educated people can do, we immediately see, yeah, we got a lot of 1s and 2s. A lot of 1s and 2s, yep. Frequency distributions. Okay, the stuff of Chapter 2. If you haven't already looked at that, look at it. See what they're doing. Descriptive statistic number 2, we call measures of central tendency. Now, some of you may have heard of this term, central tendency. If you've had another stat course, or maybe you've had a little AP stat or something in high school, the first thing that pops into people's heads is the term average. That's popular media stuff, okay? This is scientific stuff, okay? Central tendency, there's actually 3 indices. So we have three indexes. Central tendency is considered an index of central location employed, we put it to work, in the description of frequency distributions. It's an index of central location employed in the description of frequency distributions. And you notice I repeat myself. I scribble a little bit, so you know. Central location. So we're taking this distribution and we're describing it, AKA descriptive statistics, in terms of what's going on in the middle of the distribution. What's going on in the middle? And there's actually 3 ways we do this. The first way is what we call the mode. And the mode is the most frequently occurring score. The mode is the most frequently occurring score. So let's suppose we have 9 numbers. N is 9. And the data set looks like this. And again, I've put them in order for you. These numbers could be weights, right? By the way, what measurement scale is weight? Oh yeah, ratio, right? Yeah, true 0 point equal to, you need to be studying. You need to be keeping up with this stuff. I could give a quiz today. In fact, you know what? Maybe I should. Maybe I should, what do you think? Should we have a quiz today? No. Oh, okay.
I was going to study today.
Okay. We won't have a quiz. But we will have an exam in about 2 weeks. Exam 1 will be in about 2 weeks. Okay. Look at the distribution. It's obvious, guys. The most frequently occurring score is this 3. And again, this is really simple. You know, if we had a data set of 900, and these were really large numbers, and they were out of order, it would be a lot more difficult. Thank the Lord, again, we have computers, right? Most frequently occurring score is 3. Okay. Easy enough. Our second measure of central tendency we call the median. This is not the medium. It's not medium, it's median. Think of the median of a road, right? Splits the road right in half. The median of US 1 splits it right in half. It's considered the middle score. Or middle position. The middle score or middle position. Well, we look at the distribution, it's pretty obvious that the middle score is this 3. This is the median. It splits the distribution in half. The median is also called the 50th percentile. The 50th percentile. And again, I'm writing that percentage with a little LE next to it. It's the 50th percentile. It is the 50th percentile because 50% of the scores fall at or below this position. 50% of the scores fall at or below this position. 75% of the scores fall at or below this position. About 25% of the scores fall at or below this position. Now, we have a couple of rules that we have to get under our belts here. We have an odd number of scores here. So in this case, the median is indeed that middle score. But if we have an even number of scores, let's say n's 4, and our data set looks like this. We have 4 numbers. We take the 2 middle scores, add them together, and divide by 2 to get the median. So again, if we have an odd number of scores, go right to the middle. Even number of scores, add the middle 2 scores together and divide by 2. Our third measure of central tendency is the mean. The mean. The mean is considered the arithmetic average. The arithmetic average. And so when people use the term, or especially in the popular media, the average, this is what they're talking about. Last time we went over symbols, didn't we? So let's have another quiz. Let's have a pop quiz. The population symbol for population mean is what? It's the what? No, it is mu. Sample mean symbol is what? Correct, X bar. So mu, sum of the scores divided by the number of scores. X bar, sum of the scores divided by the number of scores. Add them all up and divide by the number of scores. And we get the mean. So let's do that with this. Actually, for this distribution, this data set, sum x is 27. So we can compute a mean. 27 divided by 9 gives us a mean of 3. Gives us a mean of 3. Great. Now again, you see this stuff is really simple. These first 3 or 4 lectures are pretty simple. But this is all, everything else is going to build on this. So we have a mean of 3 in terms of this distribution, a mode of 3, and a median of 3. Okay, cool. Let's draw a graph of this. We have x on the x-axis, frequency on the y-axis. Think of this as perhaps the upper right-hand quadrant of a Cartesian coordinate system, right? Positive numbers, positive numbers. Our range of x is 1 to 5. And then we have frequency. And, we could draw a frequency distribution. That's kind of a no-brainer. Look, we have 1 1, 2 2s, 3 3s, 2 4s, and 1 5. Right? We won't go through that. Let's plot some points here. We have 1 1, 2 2s, 3 3s, 2 4s, and 1 5. And this time I will play connect the dots. And I have to tell you guys right now, what you see here is not a triangle. It just looks that way because of scale. So I'm going to have to write, this is not a triangle. This is not a triangle. What this is what we refer to as a normal distribution. This is a normal distribution. Actually, the curve should look something like this, or something like this. A lot smoother, okay? Now, one of the characteristics of the normal distribution is that the mean, median, the mean, median, and mode are all identical. One of the distinguishing features of the normal distribution is that the mean, median, and mode are all identical. Now, you notice I'm not writing that down. I don't write everything down. So you need to be writing that down. This is something we need to remember the rest of the semester. One of the distinguishing characteristics of the normal distribution is that the mean, median, and mode are all identical. This distribution has a couple other names. One of the names is it's called a symmetrical distribution. It's a symmetrical distribution because if we were to fold this right area over onto this left area, it would cover it completely. In fact, 50% of the scores lie from here back, right? The median is 3, correct? So that means that's the 50th percentile. 50% of the scores fall at or below this position. 50% of the scores fall above this position. In terms of areas under the curve, which we're going to be studying very, very soon in Chapter 6, when we talk about measures of position, 50% of the area falls from here back, 50% of the area falls from here back to give a total area of about 100%. This is called a symmetrical distribution. So another name for the normal distribution is the symmetrical distribution. It also has another name. It's called a Gaussian distribution. It was actually discovered by a mathematician named Gauss. And it's also referred to as the bell curve because it's a bell shape. And again, it really isn't supposed to look like this triangle. It's supposed to more look like, something smooth like that. The normal distribution. So the takeaway from this, one of the distinguishing, the distinguishing feature of the normal distribution, other than its symmetrical shape, is that the mean, median, and mode are identical, or pretty close to identical. Now, in the real world, there are indeed many normal distributions out there. There are many normal distributions out there, but there are also many non-normal distributions out there. And I'd like to talk about some of the characteristics of non-normal distributions. In fact, let me write, and in your notes I'd like you to write, in non-normal distributions, with extreme outliers, an outlier is an extreme score. So if we had a data set 1, 2, 3, 4, 10,000, that 10,000 would be an extreme score. In non-normal distributions with extreme outliers, the mean can be a misleading measure of central tendency. in non-normal distributions with extreme outliers, the mean can be a misleading measure of central tendency. And this is a statistical concept that is very, very basic that we need to get. I mean, we need to get this. Okay. Let's pretend we're up in the state of Washington, the great state of Washington. Beautiful state. I've been up there. Unbelievable forests. And let's say we're in some like little rural district, little rural area, township outside of Seattle. And in that township, we have 6 homes. Okay, six houses. And the houses are valued $50,000, $75,000, $80,000, $100,000, $100,000. And the 6th home is valued at $10 million. Yeah. This is one of Bill Gates' homes. You know what? If I was to compute a mean, if I was to compute a mean, you know, that's some x over n. The mean would be 1,734,166. Now this is an index of central location. My question to you, class, is this. Is this mean an accurate reflection of the central tendency of this set of data? No. So this extreme score pulls the mean over into, arithmetically, this is what it does. It pulls the mean over into its direction. But if you look at, and see the thing about this, you guys, and this is, you know, like get this right now. I mean, this is why we're in school, to like learn the truth. In the popular media, when you hear averages reported, you hear that term, the average, blah, 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 blah. It's usually the mean. This is why they say statistics can lie. It's one of the reasons why statistics can lie, other than just people reporting false information. What would be a more accurate measure of central tendency in this case? Probably the median or the mode, but you know, typically in non-normal distributions, the median is a better indicator, and that's why in this case, this is housing valuations, right? You hear, you know, median housing valuations. I mean, you hear that term, and that's why they use it, because in many locations there's, you know, there's some really, really, you know, higher priced homes and, you know, and such like that. So in non-normal distributions, the mean is not the best measure of central tendency. The median is. So we always have to be, you know, careful about all this. Okay, let's do a little exercise. Let's suppose I'm an animal lover. Okay, I love dogs and I love cats, and I run over, and I live just a little north of Jensen Beach in PSL, and I run over at the Pineapple Park there, the soccer fields and stuff. And I saw a Florida panther last month. He was like 200 yards away, but he was walking along. This cat, I mean, about this big. It was really cool. And yesterday I saw some tracks. The tracks were actually as big as my fist. All right. And that's pretty cool stuff. So just thought I'd share that with you. But let's suppose we have 27 dogs. Let's suppose we have 27 dogs. We're working at this vet clinic. And let's say I'm the veterinarian, and I ask my vet tech to weigh the dogs. I'd like to get some weights on these dogs. So she weighs the dogs, and she records all the weights, and she actually gives the data to me like this. she gives me the data like this. Now you notice my handwriting is uphill, so I'm in a great mood today. Let's suppose we had 2,700 numbers displayed like this. Ooh, man. Well, you know, looking at this, you guys, can you tell me what the median is? Kind of high. So you know what we have to do? And again, thank goodness for computers. We need to put the data set in order. We have to put it in order. And typically we put it from lowest to highest. Now again, I could have you do another little academic busy work exercise and do that. I won't have you do that. I'll do it very quickly for you. We take this data set and we'll put it in order. "27 numbers listed from smallest to largest. On the exam, you'll have an exercise, where I'll give you some data sets, and you're going to be actually doing this. This makes things a little bit easier. For instance, the mode. Let's take a look at this. The most frequently occurring score. Well, we actually have two of them. This is called a bimodal distribution. Our mode is 13 and 19. This is a bimodal distribution. That's fine. Sometimes we have bimodal distributions. If you look at this really closely, you'll see that this 18 is the middle score. This is the median. And this is also called the 50th percentile. It cuts the distribution right in half. So our median is 18. We could compute a mean. Let's do that. I could have you sum all these scores. You can do that. You can add all these scores up, right? We'll save time. We won't do that. Sum x is actually 527. Our mean is 527 divided by 27. X bar, in this case, is 19.52. So we did some quick work with central tendency. We see that the mean, median, and mode are not identical. This is a non-normal distribution with a couple of modes, couple little bumps in that curve. Okay. Let's chop this thing up into quartiles. Let's do a little real general work with position. Let's go over here and just chop this section in half. I'm going to draw a line about right here. I'll call this the 25th percentile. 25% of the scores fall at or below this position. Let me go over here. I'll draw a line about right here. And I'll call this the 75th percentile. 75% of the scores fall at or below this position. I'll draw a line here just for the heck of it. I'll call this the 100th percentile. Actually, the line goes at 42, in which case it would be the 99th. Whatever, it doesn't matter. And draw a line right here, and we'll call this the 0th percentile. Now, if you look in your books, it's in chapter 3, there is also another name for the median besides the 50th percentile. They also call it Q2. Don't ask me why. I didn't make this stuff up. I'm just the messenger, okay? It's called Q2. The 75th they call Q3. And this is Q4. Q1 is the 25th. Q0.
Is it like quarters?
Quartiles. Quarters. Yeah. So this is the first quartile, second quartile, third and fourth. So this is the top quartile. This is the bottom quartile. So if you hear somebody say, "Oh, well, my son scored in the top quartile of his class, graduating," that's what it means. That's what it means. So this is saying that about 75% of the dogs weigh less than 22 pounds. There are very few dogs that weigh, and again, we could construct a frequency distribution. 1, 2, 3, 4, 5 divided by n, 5 divided by 27 is about 20% of the dogs, roughly 20% of the dogs weigh more than 30 pounds. Chapter 2 goes into this. They do all these little breakdowns. It's pretty obvious. We won't address that. What we will address, though, more characteristics of non-normal distributions. Now, like I said, many distributions out there, many distributions of scores are indeed normal. But many distributions are non-normal. Many distributions are what we call skewed distributions. I'd like to talk about skew. Chapter 3 talks about this. Skewed distributions. There are two types of skews that you need to be real familiar with. And again, this is really basic stuff. These are, this is pretty simple to comprehend. We have two types of skews. We have a positive skew, also called a right skew, and we have a negative skew. Also called a left skew. And I believe this is presented on page 82 of the 6th edition, right around there in the 7th or 8th. Positive and negative skew, and I believe the book refers to it as right and left skew. A typical positive skew might look like this. We have x on the x-axis, frequency on the y-axis. And again, think of this as an upper right-hand quadrant of a Cartesian coordinate system. With the positive skew, we have many small numbers. With the positive skew, look, we have, this is frequency, right? We have many small numbers. We have many small numbers. We could characterize that as numbers bunched in lower end of distribution. Numbers bunched in the lower end of the distribution. Tail points in positive direction. The tail points in the positive direction. The mode would be about right here. We know the mode is the most frequently occurring score. This is the point of highest frequency. See that? This would be the mode. It's a lot of twos. A lot of twos. This might be characteristic of a class who didn't score real well. Did not score real well. Lots of small numbers. The mean is about right here, pulled in the direction of the extreme scores. The mean is very sensitive to extreme scores. Median, somewhere right in the middle. So you see this mean, median, mode configuration is different than what we have in the normal distribution. In fact, the mean is a larger number than the median. The median is a larger number than the mode. In fact, let's do a test question. Remember I said you're sitting in these college classes, you need to predict test questions. What could this guy ask me? Well, here's a typical question on the exam. True or false? True or false? In the right skew, that means it's a positive skew. You need to remember that, right? In the right skew, the mean is greater than the median, and the median is greater than the mode. True or false? That's true. Yeah, see, it's true. The mean is a larger number than the median. Median is a larger number than the mode. Now, there's a lot of twos, yeah, but still in terms of the configuration, mean is greater than median, median is greater than mode. The positive skew. And we see a lot of these in the real world, in data sets. Kind of a mirror image of the positive skew is what we call the negative skew. Kind of looks like this. You have x along the x-axis, frequency. With the negative skew, as you guys see, we have many large numbers. This distribution would be characteristic of a class who did really well. A lot of high scores. So we have many large numbers. We could also perhaps phrase that as numbers bunched in upper end of distribution. Numbers bunched in the upper end of distribution. Tail points in negative direction. Tail points in the negative direction. And we know the mode is the most frequently occurring score. If we look at this distribution, this seems to be about the highest point. I'd say the mode is around 7. A lot of 7s, man. Mean, over here somewhere, pulled in the direction of the extreme scores. In this case, extremely small. Median, somewhere in the middle. So again, you see a configuration that is not like a normal distribution. In fact, we see, the mean is a smaller number in this case than the median, and the median is a smaller number than the mode. So we have a lot of large numbers. So again, it's your job as college students to predict test questions. What's this guy going to ask me on the test? You're constantly preparing, just like the swimmers are preparing for nationals and other meets. You're preparing, right? You're preparing for your test. You're going to be timed. That's a measurement. Well, the test is a measurement too. Prepare for the test. Predict test questions. What's this guy going to ask me? Well, here's true or false. Here we go. In the left skew, and that means that you know that it's a negative skew, right? In the left skew, the mean is less than the median, and the median is less than the mode. True or false? True. And that's true. Yeah. Mean less than median, median less than mode. Now again, like I said, there are many normally distributed distributions out there, and also many of these as well. There are many of these, and if you get, I know this is kind of nerdy, but if you get really good at this, you can look at a data set like a central tendency figures, and if you see, that's what I immediately, when I'm looking at data and I'm just looking at central tendency output, I immediately look at mean, median, and mode. And if mean is greater than median and median is greater than mode, I know it's a positive skew. I pretty much know the shape, and vice versa. Okay. So skewed distributions, very, very important stuff. Okay. At this point, if you ordered your textbooks, your 6th editions, you should. If you don't have them now, you should get them in a couple days. I want you to read Chapter 1 in Appendix A. Stay up with your reading in terms of the syllabus. And then that second reading assignment was Chapter 2, which is frequency distributions, and now 3 with central tendency. Just kind of keep abreast of what we're doing. I'm also going to email you some study help. Okay. One morning I actually sat down on a Saturday morning with a cup of Starbucks, and I typed out my lecture for the first 3 sessions or so, 3.5 sessions. I actually typed out my lecture text. What I've actually said in lecture. It includes all the concepts and everything. And it's called First Lectures. It's actually a letter to you. It's dear class. Dear class, and I write you a letter. Okay. I call it a love letter. So I wrote you guys a love letter. So I'm going to email that to you, as well as a list of key terms that will be in terms of concepts that will be covered on exam 1, and you'll obviously see that we've covered a certain amount of material. Print the stuff out. Don't just leave it in your inbox. It's just going to sit there. Print it out so you have hard copy of it. If it's in your inbox, you're going to, especially with your phone, you're just going to, I can look at it. Someday I'll look at it. No, print it out and keep it. Keep it with your notebook and study it. Read it 20 times. It's a great way to review. Okay. That will end today's lecture.